Being an effective administrator takes more than knowing which commands to run at a given time. This module explores some of the basic underlying architecture of Asterisk. We'll discuss many of the pieces making up the Asterisk puzzle in conceptual terms, so you can see what pieces there are and how they all fit together. Even though we won't talk through the specific configuration or commands, it will still be helpful for you to understand the fundamental order of Asterisk architecture. To make Asterisk as flexible and extendable as possible, it was developed in a modular fashion. A relatively small and simple core manages loading and unloading dynamic modules that provide most of Asterisk's functionality. This approach gives the user fine-grained control over what a given Asterisk system can and cannot do. However, Asterisk in its purest form is not completely modular. Some modules are required to be loaded for Asterisk to run at all. In practice, when we refer to the core of Asterisk, we generally mean the basic modules required to make Asterisk run, and not the dynamic modules that provide typical call services. This distinction is not overly important, but may be helpful in clarifying the rest of this discussion on Asterisk's architecture. Asterisk modules are files on the Linux system and end in .so, standing for shared object. These library files are loaded by default from the user lib asterisk modules directory, or from wherever the astmod.dir option in asterisk.conf specifies. Etc *modules.conf lets an administrator decide whether Asterisk should automatically load all modules found in the module directory, or whether individual modules must be specified to be loaded. Module load order can also be defined here. Besides managing the loading and unloading of other modules, the Asterisk core has several other responsibilities. It reads system configuration, as discussed in the Configuration Overview module. It provides system timing, so that audio streams from multiple sources can be synchronized properly, like for a conference call, and it manages Asterisk's internal channel structures. Asterisk is capable of handling many different types of media channels. Traditional analog and digital telephony channels can be configured using Digium hardware in the DADI driver package. Various VoIP channel types, including SIP and EEX, can also be used with Asterisk. For each channel type that Asterisk supports, a channel driver module has to be written. These drivers are custom-written Asterisk modules and bridge the divide between Asterisk and the technology implemented in the channel driver. Asterisk's internal data structures and functions are interfaced with the specific formatting and configuration of the standards which define the behavior of the technology. For example, the DADI channel driver communicates with the kernel drivers for Digium interface cards, and together they connect Asterisk to traditional telephony hardware. The SIP channel driver implements RFC 3261 along with several other SIP standards, while the EEX channel driver implements RFC 5456. All three of these channel drivers have the same interface to Asterisk. Asterisk offers a generic channel API or application programming interface so that a developer of a new channel only has to learn the basics of that API to write something compatible with Asterisk. They don't have to learn about all the various inner workings of Asterisk, they just need to know how channels work. The channel API includes functions for creating and destroying a call, dialing another channel, and other common call actions. By providing a generic API like this, the core of Asterisk remains independent of the channel drivers, and Asterisk retains its modular design. By convention, channel driver modules follow a naming pattern of chan underscore. Chan underscore SIP, or just chan SIP, is an example of this. Applications are Asterisk modules used for dial plan processing. The actual routing of calls within the dial plan happens in PBX core modules, but the various actions calls take, or actions done to calls, are implemented in applications. Applications implement units of functionality within the system. Dialing an extension, playing an audio file to a caller, and recording a voicemail message are all examples of functionality provided by Asterisk applications. There are over 100 dial plan applications natively available in Asterisk, and many more provided by third parties. Each application module is dynamically loaded by the core when needed, and most applications live in a file similar to the name app_dial or appdial. App playback and app voicemail are the files containing the applications I just used as an example. Asterisk allows more than one application to be invoked on a single call, but not all at once. Asterisk applications are executed synchronously, one at a time, until the call is hung up. Many applications offer a way to customize their behavior by passing one or more parameters to them when they are invoked from the dial plan. Some applications, like AppDial, even require it. Of course, it makes no sense to tell the system to make a call without specifying the destination. Functions make up another class of asterisk modules that relate to dial plan processing. Function modules offer another way of improving flexibility and control within the dial plan. While applications typically perform some action either on or to an asterisk channel, dial plan functions typically get or set some data related to a channel, which may be used to improve logging or to dynamically change dial plan routing. Among other things, dial plan functions manage caller ID, CDR or call detail records, and other channel variables. The format of file names that contain dial plan functions is the same for other modules. For the function called math, the file name is func_math.so. Resource modules in Asterisk behave in a similar fashion to applications. Their primary use is to perform some action on or to a channel, but they are statically loaded by Asterisk and may simultaneously operate on multiple channels. Music on hold is one example of this. An application would have to play a different copy of an audio stream to every caller on hold, and would have to incur whatever overhead is involved with setting up and tearing down each stream. Using a resource module instead allows Asterisk to have multiple channels listening to the same music on hold stream at the same time with little incremental overhead cost. Call recording via the res_monitor module is another example of a service provided by an Asterisk resource rather than an application. This way, call recording can happen passively while other applications run on the channel. Digital media carried by Asterisk must be formatted in a specific predefined way. An audio or video codec defines a standardized representation format and converts between that format and a native internal format. Within Asterisk, these conversions are carried out by codec modules when converting media on a channel, and format modules when converting media saved on the file system. Through these modules, Asterisk supports over a dozen audio codecs and several common video codecs. Now that we've discussed Asterisk's modular design and introduced several key module types, let's talk about the different ways you can interface with Asterisk. We already know that Asterisk reads configuration files edited by an administrator, but there are several other ways of controlling Asterisk's behavior, both scripted and in real time. The most common way to observe Asterisk status and control its behavior on the fly is via the CLI or command line interface. The CLI provides a console similar to the Linux console where you can issue commands and view results. Common commands are to show which VoIP devices are currently registered, what calls are active on the system, and to reload configuration. System help is also available. Knowing your way around this tool is an absolute requirement for any serious Asterisk administrator, so we recommend you go through the upcoming CLI module of this course to learn more about the specific things you can do here. The Asterisk CLI is a great way for a human to interactively communicate with Asterisk. But what if you want to script Asterisk behavior in a way that the native modules don't already allow? Or if you can't get CLI access? For both of these situations, the Asterisk Manager Interface, or just AMI, is a useful tool. At a high level, AMI was designed for computer telephony integration, letting a computer program control call flows. It's a simple text-based protocol that enables monitoring and control of Asterisk without using the CLI. A person or a program logs into the manager interface over a simple network socket, similar to a telnet session. Once logged in, commands can be issued at will. Aside from being an interface where an administrator can check status or issue commands, AMI is a powerful tool for scripting call flow. An external program that hooks into Asterisk via Manager can automatically dial, transfer, or hang up calls based on predefined conditions or inputs external to Asterisk. Indeed, the Manager interface has been used by many developers to create autodialers, operator panels, and call queue monitoring tools. We won't cover AMI in more detail in this course, but the Asterisk documentation and plenty of online resources exist that discuss it in more depth. The last interface we'll discuss is AGI, or the Asterisk Gateway Interface, similar to the CGI concept popular with web servers a decade ago. It allows handoff of call flow from Asterisk to an external program through a well-defined API. Using this API, people can write hooks that allow call control programs to be written outside of Asterisk. This saves a developer the trouble of learning more than necessary about Asterisk internals and makes it possible to write such programs in other programming languages. Using AGI, it's possible to offload much of the call handling to a remote server. An AGI script need not execute on the same physical machine where Asterisk is running. This helps Asterisk scale better, especially in cases where call flow scripts require significant system resources. Whereas the manager interface is generic and can be connected to at any time, AGI only functions in the course of a call. AGI scripts are initialized through a dial plan call to the AGI resource module, specifying the script to run. The script executes on the channel, and when the channel is hung up, the AGI script ends. Now you know a little bit about the basic structure of Asterisk. It's highly modular with a relatively simple core supported by various types of modules that provide most of Asterisk's functionality. You also know more about the CLI, AMI, and AGI interfaces that allow for external communication with and control of Asterisk. In the next chapter, we'll start putting this knowledge to work by setting up an IP phone and preparing to make our first call. First, though, we'll round out this chapter by learning how to use the Asterisk command line interface.